This reaction mechanism is going to be an example of a Friedel-Crafts alkylation. So this is a different type of electrophilic aromatic substitution where we take benzene, make a really strong electrophile, and attach it and substitute it on from benzene. So in this case, the alkyl group, the carbon group from this alkyl halide, ends up on the benzene structure. Right? Of course, we substitute, so something has to go, so a hydrogen was substituted for this, which ends up in the end product as an HCl there. So overall, this will follow the same mechanism from electrophilic aromatic substitution as they all do. The differences tend to be what's your electrophile and how are you making it. And this looks different, but it's actually pretty close to bromination and chlorination. We have an alkyl chloride instead of like Cl2 instead of Br2. But first step is just attaching that to the very reactive aluminum chloride. So chlorine attaches to aluminum and we form this sort of complex here. And it has some formal charges there. And this is pretty unstable. And so the way I'd like to draw these mechanisms is so the bond breaks, detach, the electrons go to the chlorine to give you just the simple carbocation. That makes the mechanism a little easier to start with. So our carbocation is going to be our electrophile here. Right? And then what do you need for this reaction? An electrophile and a base. So our pi electrons attack the carbocation. Right, so a formal positive charge on a carbon, so there's a nice strong electrophile, good to react with the benzene, even though benzene is not terribly nucleophilic. All right, so I've lost my pi electrons there and formed a new attachment to these carbons here. Right, and so there'll still be a hydrogen here, there'll be a hydrogen here, right, one for each of the carbons around benzene. The carbon on the bottom lost a pi bond. It didn't gain anything, so it ends up as the carbocation there. So then we just need a base to do the elimination. We still have aluminum chloride hanging around. And this can act as our base. So one way to draw these is the electrons coming from the chlorine leaving behind the electrons to do the substitution. So it's a little bit of a weird arrow coming from the bond, but we're kind of showing this chlorine breaking off, right? So these electrons no longer bonded between the two, but now going to attach to the hydrogen itself. All right, so now I've finished the reaction. I've gone from aromatic to just a resonance stabilized intermediate to back to aromatic. So it's always a favorable last step of the reaction. The first addition of the electrophile is always the slow step, and then everything else is relatively quick after that. Done my elimination, reformed the pi bond there, so I've got a new group attached. Still a hydrogen remaining on there, so I've got my complete benzene structure back. Of course, if it's just a simple benzene, then any of these positions could react for substitution. I'm just for convenience sake drawing in the same spot here. And since there's no other substituents around benzene, there's nothing to guide where the reaction would happen.